Hello everyone, welcome to the second part of the Lab 6A. During this session, we will see how to use the DMA transfer detection to process the ADC output data. Following the DMA transfer event detection, we will apply a specific treatment. The event might be related to one of these three events: a DMA transfer complete, a half DMA transfer, a DMA transfer error. If the detection is related to the DMA transfer complete or a half transfer, we will display the ADC output data on a terminal using the user interface 1. Let's see how we manage the DMA transfer detection event. Given that the DMA request is linked to the DMA1 Channel 1, we will apply some modification on its handler function. This function is in the STM32C0 XX_it.c file. This modification will be performed in 3 steps. For the first step, we will check if the DMA interruption is caused by a DMA transfer complete. If it is the case, we will clear the transfer complete flag, call an interruption treatment function. As you can see, it is a callback function that we will define in the main.c file. In this function, we will just set to 1 a variable that we will use further. For the second step, we will perform the same operation. We will check if the DMA interruption is caused by a half transfer. If so, we will clear the half transfer flag, call an interruption treatment function. In this function, we just set to 0 the same variable that we set to 1 previously. In the last case, we will check if the DMA interruption is caused by an error transfer. If it is the case, we will toggle an LED, the LED4, for precision. This function will also be defined in a main.c file. All the steps that are highlighted lately has been implemented in this function. Here we have the implementation of our own callback that we will define lately. So let's implement these sections. First of all, let's open our kubeiDE project. As you can see in the source files section, we can find our STM32C0 XX_it.c file. Let's open it. You can see that we have some function handler that has been implemented initially. So we have just to modify this function, our DMA channel 1 interrupt request handler. So let's open the related section. We have just to copy this section and paste it here. As you can see, all the steps that I highlighted lately has been implemented here. Here we have our custom callback that we will define. So let's define these functions. We will define them in the main.h. We declare them here. And we will define them in the main.c file. So let's do so. As we did previously, we will define our functions here. So for the DMA transfer error callback, we have to toggle the LED green. So let's enable this LED. On our nuclear board, the LED4 is connected to the pin PA5. We just need to set this pin to output mode, and we can set a label. It will be LED green. Now we can generate our project. Yes. So let's move to the next step. For displaying the ADC output data through the users1 interface, we will perform 2 operations. First of all, we will send the characters one by one until the last character is sent. After, we will wait for the transfer complete flag to be raised for the last character. To send the characters one by one, we will wait for each character that the TXE flag is raised, and then we will write each character to the transmit data register. We will perform this operation using the low-level driver. Before implementing this function, we will enable the users1 interface. To do so, we will select the users1 in the connectivity section, and we will set the mode to asynchronous one. For the other parameters, we will let them in the default mode. Our users1 interface is enabled. Due to the fact that I'm using a FTDI USB to TTL converter adapter, I will reassign the TX pin to the PA0 pin for convenience. After enabling the users1 interface, we have to switch the drivers from the HIL to the low-level one. To do so, we have to go to Project Manager. In Advanced Setting, here we have to set the low-level drivers. Our project has been well generated, so let's implement our users transmit function. We'll copy this section and we will paste it in the same section as we did previously. In this section. We will need to define our users transmit data function, and then we will move to the next step. To display the ADC output value, we will based on the state of the variable we defined on our callback functions. If the variable state is related to a DMA transfer complete or a alpha transfer, we will prepare a buffer on which we will store the message to display on the terminal, and we will then set the variable at its initial value. For precision, we are using a low-level function which will convert the raw value to millivolt. Let's implement this section. We will need to define this section in the infinite loop. Okay, so let's define also the variable that we will use in this section. This variable is initialized to 2 in order to indicate the initial state of the DMA transfer. Let's define this constant also. Our project is now ready. We have just to compile it. In this section, we will just compile our project and start a debug section. We will also run the application, and we expect that the ADC value will be displayed, as you can see here. You can see that everything is fine. Now we can run the debug section. The debug section is running, so let's run the application. We will use the Tera term in order to display the ADC output value. Here we have the Tera term. As you can see, We can observe the ADC output value. Everything is working fine. Thank you all for watching. Bye.